Ladies and gentlemen, namaskar and a very warm good afternoon to all the esteemed guests, distinguished speakers, participants. Ladies and gentlemen, this is Shank Sharma, Assistant Manager, Central Board of Irrigation and Power. And on behalf of SIGRE India and CBIT, I extend my hearty welcome to all of you to this online international tutorial on core IT technologies, AI and IoT is a powerful tool for energy supply system of the future. Ladies and gentlemen, this tutorial is being organized by SIGRE India under the aegis of SIGRE National Study Committee D2 on Information Systems and Telecommunications. I'm honored to announce that we have with us Honorable Chairwoman Dr. Olga Sinenko, Chairwoman SIGRE Study Committee D2, Mr. N.S. Soda, Advisor Strategic Advisory Group and former Chairman Study Committee D2, Mr. Gao Kum Lun from China, our eminent speaker for this program, and Shri A.K. Dinkar, Secretary SIGRE. We are grateful to all the distinguished guests for their gracious presence and valuable time for this virtual session. Ladies and gentlemen, this tutorial is planned for 1.5 hours, that is 90 minutes, where the Q&A session shall be taken by the presenter at the end of the tutorial. I would like to announce that all the participants are requested to kindly keep their mics on mute to avoid any disturbance to our presenter. And kindly use the chat box for your queries so that all the queries can be taken at the end of the presentation. This tutorial shall be taken up by one of the distinguished and eminent experts on the subject, Gao Lun from SIGRE Study Committee D2. We welcome you, sir, for this program. Without taking any more time, I would like to invite Sri A.K. Dinkar, Secretary SIGRE India, for his welcome. Dinkar, sir, over to you.
Good afternoon, ladies and gentlemen. I request you to mute your mic, please.
这个大声怎么大？
I welcome you all to this international tutorial on core IT technologies, AI and IoT as a powerful tool for energy supply systems of the future, being organized by SIGRE India under the aegis of SIGRE National Study Committee D2 on Information Systems and Telecommunication. I am pleased to inform you that SIGRE India has so far organized over 65 tutorials during this financial year, and for that we appreciate the guidance and support extended by various study committees of SIGRE in our endeavor of knowledge dissemination during unusual situations. We hope to get similar support in future too. Ladies and gentlemen, this is the third tutorial in this calendar year on the subject of Study Committee D2, and this has been made possible with the continuous guidance from Dr. Olga, Chairwoman, SIGRE Study Committee D2, Mr. N.S. Soda, Advisor Strategic Advisory Group, and Mr. Debashish Dey, Representative in National Study Committee D2 and Executive Director POSOCO. We convey our sincere thanks to Dr. Olga, Mr. Debashish Dey, and Dr. Soda for their guidance and support to SIGRE India. We are honored to have with the presence of Dr. Olga for today's session. Here I would like to mention that Dr. Olga not only helped us in finalizing the topics and arranging eminent speakers for all the three tutorials, but despite her busy schedule, she took trouble to attend all these tutorials. Today she will be covering in her concluding address the details of all the three tutorials we had in recent past. We welcome you, Dr. Olga, for today's session. We are happy to have with us today the eminent and distinguished expert on the subject, Mr. Gao from SIGRE, who shall be sharing his in-depth experience on the subject. I welcome you, Mr. Gao. We have also been joined by Mr. N.S. Soda, Advisor, Strategic Advisory Group, former Chairman, Study Committee D2. Mr. N.S. Soda, your presence and contribution always add value to such sessions. I extend a hearty welcome to you. Ladies and gentlemen, we will be joining by about 60 participants from various organizations, including engineers from Young Engineer Forum and Women Engineers Forum from Sri India. I welcome all the participants who have joined us today and would urge them to take maximum advantage of this unique opportunity to listen and interact with such distinguished experts. With this, I once again welcome you all to this session and also request the participants to join SIGRE as its member and connect with the global power system community. Thank you all, and over to the organizer, please. Thank you very much.
Thank you so much, Sri Dinkar, for your welcome address. Now, moving further, may I now request respected Sri N.S. Soda, Advisor, Strategic Advisory Group and former Chairman, Study Committee D2, to kindly address the participants on the subject. Soda, sir, over to you, please.
Thank you. Am I audible?
Yes, sir.
Good afternoon, everyone, and welcome Dr. Olga and Mr. Gao from China, who's going to deliver the lecture today. I thank the CBIP Secretary, Mr. Dinkar, who has given a welcome address just now, and all the participants who have shown great interest in the SCD2 activities. We are very honored to have Dr. Olga among us today, and certainly she is going to give her view of SCD2 activities. And I want to really compliment her for the leadership that she has provided to the SCD2 committee across the world, and the type of, the cooperative approach that she have in her leadership to give each and every member a good chance and good, support to get the best out of, the member. We have really made big strides among SCD2 activities in the last 3 years, 4 years, and compliments to Dr. Olga and the entire team of SIGRE SCD2, who have worked very hard to see that these documents, which are now being referred as the reference document across world on the information technology as well as communications for the power EPUs, it is really very heartwarming as well as heartening to learn that these documents are being referred, widely. Dr. Olga, you have really provided us absolute, support to the SIGRE India for organizing these tutorials under the COVID pandemic times, when only the webinars were possible, and today being the last of the 4, webinars that we proposed for SIGRE India. We had 3 webinars earlier. One of them, of course, was started by me about the Indian power system. Then we had Mr. Ganesh Srinivasan from Tata DDL, who spoke about the improvements and the, excellent work on the smart grid and, IoT technologies that has been done in the distribution segment in India, particularly in his own company. And the third one was by Giovanna Dondolosa from Italy, and also her colleagues, who really shared about the cyber security issues, how they are relevant and what type of standards have to be followed. In fact, cyber certainly has become, cybersecurity for the EPUs has become a concern all over the world, and India also is facing these issues as on day, and the interaction at the SCD2 level, particularly in the cybersecurity, IoT, artificial intelligence, and other subjects relevant to D2 are very, very relevant for Indian power system as well. We are thankful to Mr. Gao, who's going to speak today as a special speaker on artificial intelligence and IoT implementation. And I'll be very keen to listen to his deliveries. And we hope that he is going to share with us as to how the power utilities will be able to take benefit of the modern technologies, including artificial intelligence as well as the IoT, and how the efficiency and operation and the asset management can improve by adopting these technologies. At the same time, Mr. Debashish Dey, who is the current president of chairman of the National Committee, he wanted to be part of today's seminar, but unfortunately he is busy in the Ministry of Power on a certain important meeting, and he requested me to take his place and speak on his behalf. So I welcome all of you once again on behalf of Mr. Devashish Day also on this prestigious, last webinar and tutorial being organized. And my request to the participants as well as all the, people in the utilities that we should all become SIGRE members. And I am in particular looking for a lot of volunteers from India to work in the various working groups of the SIGRE SCD2 committee. So I'll request those who are participating today and who are also willing to participate in the SCD2 activities to kindly join and send me the email or send the email to Mr. Vishandat or CBIP SIGRE India office. So we welcome you all once again, and we wish that this seminar goes in a very fruitful manner to the Indian audience. And I'm told that the numbers today who are registered is quite high, and which is very, very encouraging. And Dr. Olga's presence is really icing on the cake. So with these words, I thank once again all of you, and I welcome Dr. Olga as well as Mr. Gao for today's webinar and tutorial. I request Dr. Olga to now take over and give her opening address as well as the 10 minutes slot she wanted. We are allowing her to take the slot. Okay, thank you so much.
Good afternoon, ladies and gentlemen. I am really very happy today to participate, to take part in this final session of Indian National Committee event dedicated to Study Committee D2 tutorials. It's from my point of view, this is outstanding event, and of course I would like to share this experience among all SIGRE community, also to inform our other colleagues, study committee chairs and members about this very, very successful event. India is huge country, very, very perspective country, and Indian experience in SIGRE activity is really very, very appreciated. So now I would like to share the screen and to start with my presentation. I hope you see this. Before starting my presentation, I would like to thank you, Dr. Sotka and Mr. Rohini Thomas and all other organizers of this event for such wonderful job. Thank you very much. So first of all, let me remind you that Study Committee D2 was presented in this event by worthwhile leading experts which are regular members or partners of Study Committee D2. So it was 3 tutorials before, and today we have the final tutorial. So 3 previous tutorials were presented around Indian power system by Dr. Sotka from India, smart grid technologies, the overview and perspectives by Mr. Ganesh Srinivasan from India, cybersecurity aspects were covered by Giovanna Dondosala, and today we have Mr. Gao Kunlun from China. Let me shortly introduce Kunlun. Mr. Kunlun Gao is regular member of Study Committee D2 from China. He is Director of Computing Technologies and Applications and Research Department in Global Energy Interconnection Research Institute of China. And he is very active member of working groups inside Study Committee D2, and he is leader of working group D2 52. So I hope that it's very good chance to have Mr. Gao Kunlun for this final session. Let me briefly remind you the main principles and area of activity of D2. First of all, of course, our main scope of activity is studying the perspective and future trend of telecommunication and information technologies worldwide. Around this, we have 4 technical directions: telecom network, network of the future, digital trends and new business services, and cybersecurity. The main instruments of working of every study committee in SIGRE is working groups, organization, issuing of technical brochure, preparing of tutorials and other materials. Inside study committee D2, we have now 12 working groups according to all mentioned above technical directions. You can see and you can participate, you as Indian SIGRE community members. You can also participate in this working group and perspective working groups. Please contact your local representative and please bring us your experience and your experience and your active forces. Now we have in study committee D2 24 regular members, 2 additional and 12 observer members from 36 countries. And inside 12 mentioned above working groups, more than 200 experts from 40 countries are sharing their experience. You can see how wide we, as a study committee D2, how wide we are in the world for our expertise, for our work. Another very powerful instrument is, of course, different sort of publications. First of all, Green Book, which is very important. Dr. Soitha mentioned about this. It's a really outstanding job. I recommend all of you to be aware that Green Book, Electricity Supply Systems of the Future, is covering the work of all cities of SIGRE community. Very, very important document. Then we are participating, of course, in technical brochures, publications, and every working group finish its job by publishing of technical brochures. The new instrument to approach not only technical expert and specialists, but also the management of electrical companies and industrial companies is Future Connection newsletter, where the publication covers the more generic issues, with explanation to management what is the role of existing information technologies, what are the future, and why they should support SIGRE activity, and of course generally information and communication technologies worldwide. At the end, I would like to draw your attention to the most important upcoming events for the next year and current year, for 2021 and 2022. We have already agreed, and it's a preparation now for symposium in Ljubljana, reshaping electrical power system infrastructure. You can see the participating study committees. D2 is not participating as a sponsoring study committee, but of course you can communicate and you can participate as authors, submitting your contribution. End of August in Paris, we have our regular central focus event. It's Centennial Session 2021 in Paris. As far as you know, this is really an outstanding event because last event in 2020 was in online format, in electronic format, and all of us, we are waiting for the end of August to again return back to the normal format. And we cannot, SIGRE community, but we cannot skip this year because it's 100 years of SIGRE activity. So please be welcome. You're welcome to this event. Look carefully and participate. Also, I would like to draw your attention for 2022 Central Symposium. From my point of view, it's very important for all Indian SIGRE community. It's dedicated mostly for distributed energy resources, for active distribution, and D2, together with C6 study committee, we are leading committee. This event will take place in Kyoto, in Japan, and I am sure by this time everything will be under control in the world, and you are welcome to participate. And finally, of course, 2022 Paris session will return back to biennial event. So you're also welcome to start your preparation. So thank you all for your attention. I wish you very good today event. Thank you again to a colleague from Indian National Committee for such brilliant organization of this event, and see you all soon for the next events, SIGRE events. Be healthy, and until next meeting. Thank you very much.
Thank you so much, Dr. Olga, for your presentation highlighting activities of Study Committee D2 and also briefly introducing the protagonist of this program, Mr. Gao Kumlun. Now, without wasting any more time, I would like to invite the speaker, the eminent speaker of this program, Mr. Gao Kumlun, with his presentation, please. Sir, over to you, please.
Hello?
Hello? Yes, sir, you're audible.
Okay. Yeah. So I have a two screen. One is for video and one is for my slide. Now, in the
yes, sir,
topic, I will close my video. Just please attention my slide. Hello?
Mr. Gao Kumlun?
Yeah.
Hello?
Hello?
Mr. Gao Kumlun, I'll request you to kindly join from one device, as joining from multiple devices is going to cause some noise in the program. So we can see your presentation.
Okay.
Yes, sir.
Hello, everybody.
Sir, there is still echo because of multiple connections from your side, sir. Sir, I request you to kindly disconnect from one of your devices, please.
Hello?
It's better now, sir. It's better. Hello.
Hello, can you hear me?
Yes, sir. Please continue, sir.
Okay. Hello, everyone. I'm honored to share my work with you in this tutorial. So the topic of my slide is IoT. It's AI plus IoT. I mean, it's the driver of the digital transformation of the electric power grid. And now the cleaner energy production and the electrification of the energy consumption have become the irreversible trends of the world energy system. The centralized and distributed new energy developed together. The high proportion of the new energy became the novelty, and the energy supply pattern is reshaped. The ability of system resource allocation and the recognition have become continue to improve. And also some other trends such as the structure of the source network and load adjustment and the multi-stakeholder and the distributed resources access. One of the most important energy and power transmission trends is the digital transformation with our advanced digital technology. The three key elements of the digitalization: one, the data. I mean, the data produced from the physical system process and the production and operation activities and from environment. And the second is the connection, the real-time interconnection of the people, machines, and things, efficient data sharing, and high definition mapping and feedback of the physical system and the cyberspace. And the third is the intelligence. The database intelligence, computing, analysis, decision-making, control, and optimization. And the IoT technology are very close relative to the data and connection. And the AI is the basic knowledge for the intelligence. So first, let's talk about the IoT first. The IoT defines as the things connect to the things in the internet, as the penetration, expansion, and extension of the internet into the physical world. The electric power IoT connects with the people, machines, and things in part of the energy production, transformation, and the consumption. It realizes a comprehensive setting of the whole power grid, generates data, and provides services for consumer, power grid, and power generation.
Excuse me, Mr. Gao. Hello.
Okay.
So can you hear me?
Yes.
Sir, sorry for the interruption. It's my request. Can you please make the slide into full screen mode?
Okay.
Thank you so much, sir. That's actually the request of the participant. If we can switch into the full screen mode, please.
Okay.
Thank you so much, sir.
Is it okay now?
No, sir. Actually, we are not able to see the slide now.
Okay.
Yes, sir.
Can you see
Please
the
continue,
screen?
sir.
Okay.
Yes, sir. It's perfect. Please continue.
Okay. The electric IoT uses massive data to drive business integration, service improvement, and business model innovation. So the power grid, the physical power grid, integrate with the IoT, we can form a new type of the energy system. It's the energy internet. The architecture of the electric IoT includes 4 layers. The sensor layer, its main function is the data collection, and as the network layer is for the data transmission, and the platform layer for data management, and the application layer for business and operation. The technology system of the electric IoT covers 5 aspects. The first one is the intelligent sensor and the terminal in the bottom of the picture. Include intelligent chip, high processing intelligent sensor, and edge computing. And then is the communication network. And above is the IoT platform, and in the top of the architecture is the application enabling technology such as the AI and the data governance and the analysis. Also, the cyber security is very important for the IoT. Include security architecture, and in IoT, the most 3 aspects is the data security, network security, and the terminal security. The intelligent sensor and the intelligent terminal is the basic layer and the data source of the IoT. The sensor terminals include sensors, electric tags, measurement devices, monitoring devices, collection terminals, and the positioning terminals. It fully realizes the state sensing, value transfer, and the environment monitoring, and behavior tracking of the generation, transmission, transformation, transmission, distribution, and the source network load storage people. Now nearly 100 kinds of sensor and terminal are applied in power grid to collect the variety of the environment value, state value, electrical value, behavior value, and physical value. And the size, the power consumption, and performance, and protection ability of the sensor cannot fully satisfy the requirements of online monitoring for the power equipment. The breadth, the depth, and the density, frequency, and the precision of sensing are restricted. The most important type of the sensor is the electric parameter sensor. Relative the electric loss and the capacitance sensing by measuring voltage, current, and the phase and the ratio of the relative the electric loss and the capacitance can be obtained. It's for judge the isolation state of the competitive equipment. And the leakage current sensing by measuring the total leakage current, third harmonic component, and the capacitive current component of the arrestor is used to judge the isolation state of the equipment. And the ground current sensing by measuring the grounding current of the transformer core, clamping path, cable shaft grounding current, judge the internal insulation state of the equipment. And the second used widely is the sound and the vibration sensing, partial discharge, ultrasonic sensing through the piezoelectric effect. The sound wave signal generated during partial discharge inside the device can be detected. Vibration and voice print sensing using the frequency spectrum characteristics of the equipment vibration signal is used to judge the abnormal fault of the equipment, and ultrasonic detection using the principle of the ultrasonic reflection and interference to detect the internal defects of the mature part and the insulating parts. And also some photoelectric sensing sensor are used to measuring the infrared spectra emitted by the object through an infrared thermal imager. Surface is for to detect the surface temperature. And the ultraviolet imaging sensor measuring the high pulse to detect the coronal discharge of the power equipment. And the electromagnetic sensor is measuring the pulse current, ultra high frequency current, transient ground voltage, and oscillating wave detect the discharge phenomenon inside insulating parts. And electric field sensing detects the transient electric field by combining a differential sensor and an integrator. Another common sensor is chemical sensing. Dissolved gas sensing detects the concentration of the dissolved gas by means of gas chromatography, photoacoustic spectroscopy, infrared spectroscopy, such as some gases, H2, CH2, C2H2, etc., to judge the isolation state of the equipment. An ambient gas sensor uses the gas sensor to detect the content of the specific gas in the air. The environmental sensing technology, the environmental thermometers and hydrometer sensor, water immersion sensor, smoke, noise, temperature current recombination sensor. Besides, some advanced sensing technology appears in recent years. There are current sensor based on the new metro-resistive materials have the advantage of low cost, easy charge installed, and are suitable for development in consumer-side environments with wide coverage, multiple line branches, and large load chains. And the partial discharge monitor and the positioning, a multiple functional integrated intelligence sensor. And the intelligent algorithm can be deployed on the sensor to form a scene-in computer system. The fault identification response speed and positioning accuracy can be improved. Also, we can use the sensor and the primary equipment fusion technology, such as the system in package, SIP, and the MEMS and the NEMS power-specific sensor devices can be developed to promote the intelligence of the electric equipment. This is a sensor layer of the IoT. And for the sensor edge computing, there's the edge IoT agent, realize the unified collection and the centralized aggregation of the data from sensors and meters, and support edge intelligent computing functions. In the agent, they have operating system and basic software platform and some apps for different business. And in the communication network layer, with the development needs of the electric IoT, the power communication network coverage, transmission bandwidth, and the security access capability are still need to improve. The main challenge of the IoT are massive connecting, low latency, high reliability, reliability, and low power consumption, mobility. For broadband communication, we can use technology such as 4G, 5G, and Wi-Fi. The 5G can be achieved ultra low latency of less than 1 milliseconds, ultra large bandwidth of 1 Gbps per second, and the ultra large connection of 1 million users per square kilometers. And the efficient, safe, and reliability are also supported. So, it's very important. The character of the 5G is the network slice. And for the narrow bands with communication, we can use the NB-IoT or LoRa. The legend spectral low power wide area communication, NB-IoT, or unlicensed spectral low power wide area communication technology such as LoRa to achieve sensor with a low power consumption, low cost, large connection, and long distance transmission of the micro power and the low power sensor. The IoT managed platform with function of the connection management, network management, equipment management, and user management, and provide resource configuration, data aggregation, and basic management services. Through cloud computing, a unified SaaS supporting system is built on the platform to achieve the expansion of the service capability. And analyze, process, and visualize of the data from the sensor, and the distributed data from distributed the data to the data platform. The last is cybersecurity. The IoT extends the power generation side to the customer side. It's necessary to extend the security protection to the IoT terminal equipment and on-site network. So the main security technology includes lightweight cryptography technology, distributed identify, authentication, and dynamic authority management to ensure the data security, network security, and terminal security. Here are some application cases from the IGCC. One is the resource side application. It's a traditional generator sets and a new generator station. For traditional generator sets, they will use a lot of sensor. That's in the picture: speed sensors, short circuit monitoring devices, and the bearing sensor, and temperature sensor to achieve a more perfect online monitoring of the generator status. And for new generator station, the level of the refined operation and maintenance can be improved by using high-definition cameras, drones, and various environment sensors listed in the picture. And on the grass-side application, the typical application is the monitoring of the overhead transmission line. Real-time online monitoring for the transmission line can be realized by using sensors such as tension, three-dimensional acceleration, and inclination. Systematic analysis of the operation and maintenance status, diagnosis, and early warning risk assessment are realized. Use the following sensor. And also we need the environmental monitoring of the transmission line passage, such as micro weather sensor and temperature and cameras. And smoke. In the pipe cable, using the temperature and humidity sensor, water immersion sensor, harmful gas sensor, and smoke sensor, and high definition cameras, and other devices to ensure the safety of the power transmission pipe cradle facilities and the inspectors. In the substation, the status monitoring and the fault diagnosis technology are used. The voltage and the current signals can be collected by the sensor and measured using the electromagnetic transformer. Partial discharge monitoring on the transformer reactors, Gs, and the circuit breakers are realized to evaluate the insulated status. And using the video, voice print detection, all-ear chromatographic monitoring, and other sensors combined with the edge computing, the intelligence identification of the defects in substation equipment, pre-identification of latent defects, and the intelligent state early warning are realized. And there's a lot of sensors used for the power quality for distribution network. In demand side, we can use the Vantage IoT application to actually span the water, gas, heads, and the co-signal access, equipment operating status sensing, energy efficiency analysis, and diagnosis, and other function can be achieved. And also in the new cases is a virtual power plant. Also need a lot of sensor and all kinds of the smart sensing technology to minimize comprehensive energy efficiency. And in the future, smart grid and electric IoT developed together to form an energy internet that integrates energy flow, service flow, and data flow. The electric IoT will form the powerful value-created platform, greatly improve the operation and the services capabilities of the power grid, and lead the development of the energy and the power. So the working group of the electric IoT technology and application is established in Secret D2 in the last year. The goal of the group is to establish a set of IoT platform solutions for relative services in power industry, including terminal suggestions, practical cases, and standard design suggestions. And the work group now have the 20 members from 13 countries. The below is the chapters of the technical branch of this group. It includes IoT architecture design, cloud edge computing, collective computing, interface and protocol design, sensor access, interface and communication, security design, and information model. And in the journal this year, we published an article, Technology and Applications of Industrial IoT in Power Industry. In the fifth issue, Future Connections. Okay, that's a topic about IoT. Then it's a topic about the artificial intelligence. The artificial intelligence is a set of the theories, methods, and technologies and systems that use the artificial system to simulate, extend, and expand the human intelligence. There are three types of the intelligence. The first one, perception intelligence, such as the machine computer vision, speech recognition. And the second is cognition intelligence, such as natural language and processing, dialogue, reasoning. And the third one is the decision-making intelligence. With the development of the AI for more than 60 years, we have 2 booms and 2 declines. And the new generation of the AI technology, represented by deep learning, has promoted the third wave of the artificial intelligence. The deep learning network model is very complex. They have a large amount of the parameters and high dimensional data feature extraction abilities. So it's very close or even surpasses the human level in many fields, such as the image recognition. And the driver of this deep learning is algorithms, big data, and computing power. In the power industry, the AI was also applied from 1970s and the 1980s. The first stage of power industry is the expert system and the artificial neural network applied to power fault analysis and the load forecasting. And the second stage, from the middle of the 1980s to the first years of this century, we use the machine learning technology such as SVM to power system dynamics security estimation, and nonlinear optimization. And in the last 10 years, the new generation of the artificial algorithms such as deep learning and reinforcement learning are applied in the field of the equipment defect identification and power grid stability judgment. This slide shows the architecture of the AI is very complexible. And in the bottom of the picture is the infrastructure layer. It includes hardware processor such as CPU, GPU, NPU, and some basic software like operation system, compiler tools. And then next layer is the data processing and the AI computing framework. PyTorch, TensorFlow, and PyTorch. And above this is the algorithm. It's a kernel. In my opinion, it's the core technology of the AI. A lot of algorithms support AI working. They are optimizing algorithm. Learning paradigm includes supervised learning, semi-supervised learning, and unsupervised learning. And a lot of learning methods are deep learning, adversarial learning, transformer learning, and federated learning. And some traditional model are such as the SVM-based graphic model, and some deep learning models such as the convolutional network, graph neural network, and so on. And in the top of the architecture is the application technologies. There are five main technologies of the AI. First one is the data analysis. It's used for the analysis and for the structured data. The typical model or algorithm is the naive-Bayes K-means SVM. And then second one is the computer vision. It can do some image classification, object detection, image segmentation. The typical algorithm is includes CNN, RCN, and so on. The computer vision can let the machine can understand what they see, just like the human being. And the third one is the NLP, natural language processor. This technology can let the machine understand what understood the text and can dialogue with the human beings. The typical algorithm is the LSTM, CRF, and topic modeling. Also, the knowledge graph is very important for the power AI. It can help us to knowledge acquisition, knowledge fusion, knowledge representation, and knowledge reasoning. And another type of AI is the agent O. It can make the machine can act like the human being. These five types of the technology also according 5 types of the task in the power system. Let's see some application today. One is the smart transmission line inspection. The transmission line has widely distributed, and the outdoor environment is very complex, and the manual inspection are very heavy. We use deep seeing and other image recognition technology to realize the intelligent detection and analysis of the line defects in power transmission inspector pictures. And online cloud services are provided to hundreds of line inspection teams through the State Grid Cloud platform. Using this technology, the daily average number of the inspection pictures exceed 5,000, and 90% the defect can be recognized by the machine. The work efficiency increased by 60 times. This picture shows some typical defects in the line. And in some cases, the AI can do better than the human beings. In this picture, in the left, is image with 5 million pixels, and the defects such as missing pins are just less 20 pixels. It is impossible for a human being to find the defects, but machine can do this very well. And in the substation, by using machine learning, knowledge graph, image recognition, and intelligent robots, it can realize the substation equipment status monitoring, defect, accelerate research and judgment, and intelligent patrol in the station. It's improved working efficiency and equipment defect discovery and processing capability, promote equipment intelligent upgrades and management digital transformation. And using this technology, the 80% reduction in manual workflow is achieved. And in the distribution network, we use technology such as multi-sensor fusion positioning, autonomous path planning based on the reinforcement learning, and cable target detection based on the image recognition technology. Development of the distribution network operation robots effectively eliminates the personal safety risks of the traditional manual operation, greatly reduce the labor intensity and improving the quality. And we also develop a wheelchair dispatchers. They can conduct the dialogues with the on-site operator through NLP-based multiple rounds man-machine dialogue engine. Check the operation content on on-site personnel based on the knowledge graph of the distributed network. Check the status of the power grid equipment and direct on-site personnel to conduct the lines, maintenance, and other operations. And it can take over 85% work of the human dispatch. And they can avoid waiting in line for incoming calls during the peak hours. Also, the AI technology is used in the customer services. We development intelligent customer service center using the speech recognition, NLP, and natural language understanding and knowledge graph to provide high quality, high efficiency, and convenient and intelligent services through the multiple channels, such as the telephone and the internet. The intelligent voice manual replacement rate is about to 45%, and the online feedback replacement is about 57%. In recent years, some researchers have explore the application of the deep reinforcement learning to realize some critical business, such as grid operation control, the learn to run a power network, competition held by RET, and our team win the competition in the last year. Using the large-scale and fast non-linear control ability of the reinforcement learning, the control effect and speed can be achieved far beyond the human level. And we also deployed cameras at the construction site using the CV technology and the video stream analysis technology to automatically identify the on-site dangerous phenomenon and violations to reduce casualties. Besides these 5 technologies, there are also some new advanced computing technology to promote our industry to intelligence. One is graph computing. With advanced computing and advanced data process capability, integration with the knowledge, with the power knowledge, the performance of the large-scale power grid multi-data management, complex topologic analysis, and the intensive power flow calculation has been increased by 10 to 100 times compared with the traditional method. And graph computing can also support AI technology, such as the knowledge graph and graph neural network as well. Although the AI have application in so many aspects, we also face some very large challenge now. One challenge is about the data. We call this small sample, because in the power industry, some very extremely faulty default seldom occurs, so the samples are extremely few. And we also face the challenge of the safety or the vulnerability of the AI. In the recent years, more and more attacks are created for the AI system. Also can attack the training samples, attack the AI models and the system. In some cases, a small disturbance can be lead absurd and fatal mistakes. And another challenge is the explainable and trustworthy of the AI. Because the deep learning network, the training is like a black box. They can't give the evidence of the reason of the results. So we don't know why the answer is yes and why the answer is not. So in some critical business, we can't trust the AI as the human beings. And another challenge is the migration ability of the models. We hope the similar and the relative task can reuse the same model, but unfortunately, it's not today. And also, we hope some algorithm or AI models can running as well as can running in the terminal or edge devices, which with limited resources, but they can't. And there are also some other challenges there, such as the privacy, such as lower restrictions. we hope in the maturity of the AI theory and the development of the technology, we can get some technical breakthrough, such as explainable deep learning, safe and reliable intelligence, data and knowledge integration driven AI, and hybrid enhanced intelligence, cross-media intelligence. With this breakthrough, the AI system has the ability to autonomously discover the knowledge and autonomously optimize the decision making in complex environments, and is fully applied in critical business such as power generation, grid dispatching, just like R5 autopilot in the grid. It's our dream. At last, I would like to have a brief introduction of the secret working group D255. It's the AI technology and application in power industry. It's also improved in the last year. The goal of the working group is promote the innovation application of AI in power industry and promote the digital transformation. By now, we have more than 30 experts from the power transmission, distribution, and equipment vendor research institute and universities. Our task is provide a technical branch and a relative tutorial. The chapter of the technical branch is below here. It includes introduction, AI requirements and target, AI technology framework, applicable and maturity of the AI technology, typical practice, new challenges, and roadmap. Welcome more experts join us. Okay, this is about our topic. Well, thank you.
Thank you so much, Mr. Gao Kumlu. Wonderful and informative presentation. Now I would like to announce to all the participants that the panel is open for discussion. Anyone who wants to interact with the expert is most welcome to do so. I would like to take the queries that are in the chat box one by one. Mr. Gao Kumlun, are you there, sir?
Yeah.
Sir, can you see the chat box, please?
You kill me?
Our first query is from Mr. Enis Soda. Soda, sir, are you there?
I'm there. Yes.
Yes, sir.
Oh, okay. I see the question.
Soda, sir, it will be great if you can ask your query verbally, please.
About 5G communication, now some pilots in just the pilots in China now. Can you hear me?
Yeah. I mean, is it being used or is it still in the developing stage, 5G communication?
2 years.
What is the status of 5G in China as such today?
Just a pilot.
Trial, okay. Okay,
Not
thank you.
Large scale, not large scale.
Okay, thank you.
Thank you, Soda, sir, for your query. And the next query we have from Mr. Rastogi. Mr. Nimish Rastogi, sir, are you there?
Sir, yes, I am there.
Yes, sir. Please interact with the expert.
Good afternoon, sir.
For the question, I'd like to invite the two experts from my team to answer the question with me. This the Dr. Lu and the Dr. Wang.
We welcome you, sir.
Thank you so much. Yes, welcome.
Yes, hi, sir. Good afternoon. Nimish Rastogi this side. So I had a query with respect to centralized control for demand response system. So in China, do we have that system in place, or is it still in the trial phases? So when we talk about the demand response system, so for the distribution network, so we do have the monitoring, but when we talk about the control from the IoT via the cloud, so is that infrastructure in place, or how is it there in China?
Mr. Gao.
Yeah.
Yes, sir. Please go on.
Some is in the centralized control center, and some is distributed in the
compute in the compute。然后他问的是有没有需求侧响应。
Yes, there's some.
I hope the question is clear to the Mr. Gao. Is the question clear to you, Mr. Gao?
Yes, yes.
So what is the answer then?
The answer is we have some centralized control in the center for demand response.
Okay.
Thank you, sir.
Is it my number again, the organizers?
The next question is from Miss Priya. Miss Priya, are you there?
I'm there.
Yes, ma'am. Please go on.
Actually, I want to ask about LoRa communication. So, which type of LoRa you are using, and which in which environment?
Okay. We have used the LoRa as last 1 kilometer communication access technology in the power grid. For example, in the substation or in the transmission lines, we use LoRa to connect the terminal sensors, and the data are collected, and we have this data to have a good analysis.
Okay.
Miss Priya, are you fine with the reply?
Yeah, that's okay, I think.
Okay. Soda sir, it's your turn now, please.
In fact, you have covered artificial intelligence in a big way, particularly how the artificial intelligence building blocks are there. My question to you is that you have very large transmission company like State Grid China. Mm-hmm. Are there AI technologies which are being used now? Can you mention few of them?
那个还是那个输电线路的那个，你可以把那个 PPT。
So let transmission line inspection with AI in this slide. The question is.
Yeah, they are being used, I mean, as an asset management tool, or are they really integrated into the artificial intelligence and providing you the diagnostics as well as the solutions about the outage?
Yes, this AI, this application is in the about 15 province company, province company of the state grid, and the
answer is not clear. Answer is not clear.
Well, yes. Well, this application is used by China's transmission grids, and it has replaced like 50% of manual work in our daily maintenance and daily operation.
So there's the automation part of it. I was asking about the artificial intelligence. Or
Yes.
giving you intelligent information on when to do what, and whether the system is good enough to carry on with the fault for a longer time.
In fact, you can have a look at this picture. Well, in this picture, there is a little pin missing problem, and normally we cannot find it with our human eyes, but with our artificial intelligence agent, it has some computer vision technologies, and it will detect automatically the problems with its machine learning model.
Okay. I think the integration part is still going on. To me, it appears that, well, lots of, modern diagnostic tools are being used, and the data is being fed to the system. And that data is being, analyzed at a central data center.
Mm-hmm.
And then you are coming out with some intelligent reports about the condition of the asset, as well as, the action plan required to attend it. Isn't it?
Yes, in fact, we have the helicopters and drones to take the pictures, and then we will process the pictures in our data center.
Okay, good. Okay.
And additionally, we also put some computer on site with the structure, so we can, when we finish the flight, they copy the picture to the computer. We can do the same thing on site.
Do you also have something like a national Chinese asset management center for the entire transmission assets? Is there a national center to monitor the assets across China as a whole?
I think there's some, but not in the slide. I will probably later.
Okay.
Yes.
Okay. Thank you, Mr. Gao.
Thank you.
Okay, so the next question is again from Ms. Priya. Ms. Priya, are you there?
Yes, I'm there. Just need to ask that some use case or case studies you can mention in smart grid area based on AI applications.
AI 就是在中国有没有什么现成的智能电网相关的 AI 应用？
The application cases in the slide is a real application in China. All this application is a real use cases. It's not just the research, it's real work.
Okay, this is the robot you are using for network operations, for distribution network operation.
Network operation. Oh, we just the network operation just in distribution network, but not the high voltage network. We are very
cautious.
We're very cautious.
Okay. Thank you.
Thank you.
Thank you, Ms. Priya. The next question is from Mr. Biswas. Mr. Biswas, are you there?
I'm there.
So please go on with your query.
Actually, is there any AI-based technology for demand-side management in distribution network? Is anything happening in China?
Oh, for demand side management in distributed network. I think because my team is from the IGCC, and the cases is also focused on the grid. I think there are a lot of demand side management AI application, but I think this slide is relative with the demand side, the virtual power plant. We collect the controllable load to act as the virtual plant to support the operation of the grid. And this demand sets and a lot of integration energy services provider do this kind of job, but not the power grid. Hello?
Thank you. Thank you.
Mr. Biswas. Okay. So, ladies and gentlemen, Mr. Soda, we can see Mr. Soda's hand raised up. Mr. Soda, would you like to ask any other query?
Yeah. In fact, you had shown lots of interesting, slides on various type of techniques that can be used. But as an expert on AI as well as on the IoT, would you please say in few sentences how a distribution utility which is running into loss today can be made into a vibrant, smart distribution utility?
So
Pardon?
Is it clear, the question?
I'm not sure. Would you please repeat it?
Okay, I repeat it. A distribution utility is running into losses because of high, distribution losses or thefts. How can the distribution losses be reduced and made this distribution company as a vibrant and smart, grid compliant distribution company? What are the steps that you suggest?
I think there are a lot of traditional method to the distribution loss, and the IoT and the AI algorithm can help them do better.
Okay, I think a very brief answer he has given. If there are more questions, I think the organizers can request the audience to talk to them, or maybe we can start closing the session then.
Okay, ladies and gentlemen, any more questions from your side for the speaker? This will be the last announcement for the Q&A session for this program. Okay, so thank you, ladies and gentlemen, all the participants for your queries, and thank you so much, Mr. Gao and his team for taking the queries one by one. Now, as there are no more queries, so we'll wrap up the session for now. Ladies and gentlemen, I would like to announce that with permission of Mr. Gao, we shall be sharing his presentation with all of you in your registered email IDs. So, and also you might have received the information about SEGRE and joining SEGRE, so kindly consider doing so. Now, moving further, I would like to invite Joint Advisor Central Board of Irrigation and Power for his vote of thanks, please. Mr. Batra, over to you.
Good afternoon, ladies and gentlemen. It is my pleasant privilege to propose vote of thanks at the end of this international tutorial on core IT technologies, AI and IoT as powerful tool for energy supply systems of the future. Organized by SIGRE India and CBIP with the support of SIGRE Study Committee on Information Systems and Telecommunication. We are grateful and convey our sincere thanks to Dr. Olga, Chairwoman, SIGRE Study Committee D2, Mr. N.S. Soda, Advisor, Strategic Advisory Group, and Mr. Devasys K, National Representative in Study Committee D2, and E.D. Usoko for their guidance and support in organizing this tutorial. Our special thanks to Mr. Gao Kumlun from SIGRE Study Committee D2 for his valuable time and support to us by delivering wonderful presentation today. I would also like to thank all the participants who joined us for the tutorial and appreciate their interest in the subject. We are grateful for your support in our endeavors. We are also thankful to Secretary CBIP for his valuable guidance to us from time to time in organizing such events. Last but not the least, I would like to thank you anyone and everyone who made this tutorial possible. Thank you all once again. We look forward to your participation in our future events, please.
Thank you, Mr. Patra, for your vote of thanks. Now, with that, ladies and gentlemen, we end the session for this program. I would like to thank everyone who took the part in organizing this program. Special thanks to the dignitaries who were present in the program, Dr. Olga, Shri N.S. Soda, and our eminent speaker for this program, Mr. Gao, and also to all the